Hello, hello. Welcome to the meeting number 8 of movement validation. So we're in the middle of a discussion right now. You've joined us 20 minutes in, but we are talking away here. So Jim, have you got your audio? Oh, I see. He's still thinking about it. Okay. So maybe if there's anyone listening on the stream, then maybe I'll just give a little organizational update here of what's going on, and I'll give a link to the agenda for everyone to see later. Okay, so yeah, so let me talk about the progress that we've made towards the MVP, minimum viable product. So we got statistics code ported and available. So that's one last step there in the pipeline. We have the ability to calculate parametric and non-parametric P and Q values for each of the features. And we can for example, ask for these statistics to be calculated on a group of, let's say, 10 experiment worms against 10 control worms, and we can select any number of experiment and control worms to perform these tests on, just like the original Schaefer code did. And now we're in the midst of trying to show these statistics on top of the histogram plots that we've created in the same format, or as close to the same format as possible, as the PDFs that the Schaefer Lab code originally showed. So we're in the midst of that. Chris, Lindsay, and I are working on that. So what else? Pre-features. So Jim and Avelino and myself, I guess, worked a lot on pre-features, and sounds like Jim's got his audio working. Maybe I'll mute you because you've got some feedback. Wait, I think it's the other one. There we go. Yeah, so pre-features, and we not only that, but we have tests for our pre-features working now, so that's great. We've got several unit tests on that working away, so that's good. So a next step for the minimum viable product, I think, would be to create an example JSON file of simple worm movements to see if the calculated statistics look the way you'd expect them to. Like, for example, if a worm's not moving at all, just sitting in one place on the screen, then perhaps that would show a very low Q value and P value for dwelling, for example. So that's a next step, and I'll work on that. And after we have such an example, we should be able to hand that example off to the Geppetto team to create an extract from their system in the same format, and then we'll be done with our minimum viable product, because we'll be able to show statistics for the actual OpenWorm simulation. Meanwhile, there's a lot more work obviously happening all over the place for movement validation, not just focused on that more narrow pipeline. In particular, after the C. elegans conference at UCLA in late June, there was a significant discussion about a kind of an open worm tracker standard, so standards around common metadata and video formats, and there's been a lively discussion about that on email chains, and some of that's been collected into a new repository that Steven started called Worm-Tracker. So hopefully we can develop a standard there that we can follow for movement validation. So the idea there is we have this open standard that anyone could potentially implement, and movement validation can be one implementation of this tracker standard. So that's basically what's happened in the last month. So quite a bit of stuff at a high level. Maybe we can all just talk about what we've done individually and hopefully get some discussion out of that. So Jim, I have you first on the agenda here. Do you want to talk about your stuff with like Travis CI and refactoring and everything?
Yeah, sure. Can you actually provide the link again? Just because I had to switch over.
Yeah, sure.
I think I already had talked about Travis.
That's fair.
But I don't. So actually, I think we still have a little bit of work left on that. Um, primarily, I had only gotten it working for one version of Python, and although I don't think that's going to be too critical, I mean, it would be nice to get 2.7 support on there.
Or 3.3 for that matter.
I think the one I chose to implement out of all of them was 3.3, just because I got sick of trying to get all of them working at the same time. So that's still an open issue somewhere on our issues list. I think that the main thing to point out to the group is the work that I did towards refactoring the features. In particular, what prompted this, and I don't have the issue in front of me right now, was Michael's comment that these features get broken up into contingency features, or like expanded features, I think, as we've called it at one point, where basically we say, well, what is this particular value doing when the worm is moving forward or backwards or not moving at all? And Michael had suggested that we build support for handling that into the feature itself, rather than having a whole nother set of functions that have to go through and extract out these features. And I think, Michael, do you have that issue up, or do you know which one that is?
I can find it as you talk. I'll find it for you.
Great, that'd be great. So Michael put it that way. What I came up with instead, or what got me onto the path that I was working on, was some of the features were not working, and I wanted an easy way of going in and basically only examining the features that I cared about. And so, for sort of a somewhat different reason in that case, compared to what Michael was talking about, I felt the need to reorganize things a little bit, to refactor the code. And so what I've just completed, although it needs a little bit of cleaning up, and there's still some things missing, is basically each feature you can now just compute directly. So if you only care about crawling bends, you can say, give me the crawling bends, and that would be the only thing that would be computed. And the dependencies that were there, they'll be handled for you. They'll be calculated as necessary. What that then would also allow us to do is get back to Michael's original concern, which is because each feature is its own encapsulated object at this point, rather than just being NumPy arrays, we can do things like build-in methods that go to the histograms within that feature, and I think provide a little bit better encapsulation in that sense. The code for this is, for better or worse, built into the current master branch. There is a test case which will just bring up a debugging line, but I think I can show the group relatively quickly. If I can find, okay. So here's the link to the test that I wrote, and what it'll basically bring up is it'll bring you to a debugger in a function in worm features called worm features dose, which, just to clarify, in case it's confusing, is just reference to number 2 in Spanish. Eventually, the goal is to take worm features dose and make that worm features main. Once I haven't broken all the tests, which currently I'm breaking right now. So that's a big effort that's basically done, but still needs things like loading to be handled, loading of old features, needs the comparisons to be handled, and again, most of this is just moving code around, and then also support for going into the histograms.
So Jim, can I ask a question about this?
Yeah, I was going to say, if there are any questions, now would be a great time to go for it.
Okay, cool. So what I'm seeing here in this example, the only change to the code is, well, you're saying, okay, it's open worm features equals mv.wormFeatures dose, and you're passing it a normalized worm object. So that's exactly the same interface that we currently have. So from the perspective of an end user, if you will, or from something outside of the features package or sub package, there's no API changes.
As of right now, there aren't. So what that's doing is that's going to compute all the features just like we currently do. If you look into the specifics of that code, you'll see that the first thing it does is it loads up information on basically how to compute each of the features. The idea with that then is you could separate this into a two-step process, which first is give me all the features or run some query over which I can somehow specify the types of features that I'm concerned about, and then go ahead and actually compute only those features. So as of right now, yes, it's exactly the same. In the long run, it offers the potential of looking at those what I'm calling specifications on how to create these features, and just choose the ones you want and run only those, which previously would have been very difficult to do.
Great.
And so I think that's it on my end.
Okay, yeah, and I was going to say it definitely makes a lot of sense to have a table of specifications where you're saying, well, here's the feature name, here's what it's about, here's its category, whether it's a movement feature, whether it's a locomotion feature, a path feature, posture, morphology, and here's its type, and here's some more information about it. Maybe even here's the lab that came up with this particular feature or that is concerned about it, and then also thanks to your work here in the table itself is here are the dependencies that the feature has. So here's what it depends on knowing to calculate itself. So everything is explicitly laid out, the dependencies, rather than it being sort of just in the code somewhere you have to trace that and figure it out. So that's really good.
So actually, I feel bad. I just removed that feature.
What?
But I think there's a good reason for it, which is
okay.
Well, I will let the group decide, and we can put it back in relatively easily. The code has a framework now for basically whenever it depends upon something else, it makes a request to the worm features for that feature. So in other words, if you depend upon the mid-body speed for some feature, which some of them do, you basically say, hey, worm features, I need the mid-body speed. And what then becomes really easy to do in that particular case is, since it's this one querying method, you can then write onto it, by the way, this particular feature needed this other particular feature. And so from your code, you can build these dependencies up relatively easily. So in other words, the reason I sort of took it out of the file, and I'll paste a link to the file here, what it currently looks like, is there was a lot of manual entry that I was doing, and the accuracy of that was not entirely clear. At some point, I think I made a mistake, and so then I was like, you know what, this is sort of duplicate information, I'd rather just not have it. So if we do want that information, I think it's something that if someone sits down and runs all of the features, we could generate a tree relatively easily that would show this type of information. But I thought it would be better to have it intrinsically built into the code rather than a stale entry point that I had added manually that may or may not be up to date. So the type of information you see in the CSV file, if you pull it up, I just posted a link into the chat, is essentially what are we going to call this thing, which is the feature name. I'll get into the first thing in a bit. But if you look at the second column, feature name, what are we going to call it? Which module is it in? And within that module, how do we actually reference the function that generates the feature I care about? And then finally, flags is really just a string entry that gets passed into the particular function if it's there or not. And that allows me to do things like call one particular function with slight variations, in most cases based on what section I'm processing. And that's the entirety of it, but pretty much everything there needs to be there. And so that was sort of the thinking. Just for completeness, the is feature, uh, basically, if it's a yes, means that it's something that we eventually would down the road would have held on to, versus um, the no's, which are intermediate calculations that appeared. So the one that I remember off the top of my hand is orientation. In general, we tend not to care what the orientation of the worm is at any particular point in time as far as an overall global feature. However, we need that for future calculations. There's some dependencies on it. So that's what that yes or no is. And really, I haven't done too much with that yet, but that's what that column is, just for completeness.
Okay, fair enough. And there, yeah. So I just did a screen share, so people who don't have the link to that, you can see that here.
It's not showing up.
Is it showing? My screen isn't showing the information?
Yeah, not for me, but
okay.
Then again.
Well, not the end of the world. Okay.
Yeah, but what I was going to say is that, so what you were talking about, generating the tree of dependencies.
Yeah.
I actually tried to do that a few weeks ago. I guess it was the July 4th weekend. When I was basically in connection with the feature explanation branch.
Yeah.
I came across this library called PyCallGraph, and so that's basically what it does. Is it runs, so it'll run a snippet of code and it'll track everything that's called in running that code, and it outputs a Gephi file. So I was able to, let's see if I.
Cool.
It looks very pretty.
Yeah, I mean about the only thing is obviously when it runs, it runs like all the way. It basically just bottoms out in primitives. So
Yeah.
the output graph is quite dense, but you can filter on the module. So basically, you can just pull just the stuff that's movement validation. But
right.
Yeah,
yeah, we wouldn't need this really base stuff here, but if we could filter on it, yeah, that'd be interesting. That'd be an interesting way of visualizing it.
Cool.
Yeah.
Any other questions, or that's basically it on my end?
Well, so to do what you were talking about, the building the calls, is that documented in your code here?
So I need to apologize. I basically finished this yesterday after many days of working on it. Over the course of probably the following week is to actually document these things so that people can actually use it.
Okay,
right now, there's basically no documentation for it. But it'll come soon, and when it does, I'll let everyone know. And actually, Michael, did you find the issue?
Yeah, 133.
Yeah. So my intention is to basically add on more documentation to this issue 133 in addition to just general documentation put into the repository. And Chris, I'll make sure to include you when I add on a discussion about completing this.
Cool. Yeah, because like I said, because that was what I started doing, building that dependency tree to try and understand the code a little bit better. So yeah, be very helpful.
Yeah, and just here's if this Lime link works as an example. This in part I didn't mention this before, but was motivated by I believe Avellino from Andre's lab, who very much disliked sort of having to go through the nested structure and pull out some of the values that were taking the features and basically flattening them out was frustrating for him. So in the link I provided, I believe it's to crawling bends, and the code I think is relatively straightforward, where you have locomotion, crawling bends, and then in this particular example, the bend name, which would be something like head or tail or mid-body. Again, I apologize. You can see there's basically no documentation of these things. But importantly, now in terms of the granularity that we're getting down to, and I think we have some room to improve in terms of our inheritance structure to remove some redundancies. But basically, the only thing that this feature, this bend amplitude feature, is doing is taking a previously computed value and extracting its amplitude attribute. So that then becomes a singular feature. But what you notice is right now I've implemented this as a dictionary retrieval. So WF is referring to the warm feature object itself, and then I'm doing WF of the parent name. And so that's essentially calling this pre-computed feature and getting then subsequently on that line getting its amplitude attribute. Within that, though, it'd be relatively straightforward to envision creating some method that basically adds on, oh, by the way, in order to compute this, you needed to get this additional thing, this additional feature as well, or temporary feature as I've been referring to it. Anyways, that may be helpful or not, but that's sort of it gives you an idea about the granularity of the things that we're going down to. So now each feature that you actually care about in the end has a dot value, and that is, in most cases, just a NumPy array. In some cases, it's a scalar when it comes to some events, but mostly it's NumPy arrays.
I should mention that if, for example, Avellino's use case, if it's about flattening the structure, one way to do that is to view it as a pandas data frame, and I did a little work enabling that. So the idea there is, and this is just another way of looking at the data. So I in my experience, it seems like there's various use cases, various ways to look at the data. So so what you've done, Jim, is great, and another way to look at the data might be, yeah, through a pandas data frame, and with worm features dot get data frame. Now you should be able to just to do that. So, for example, if you wanted to calculate some metric on frame 5, and you cared only about whether there were nans or something across all of the features calculated in frame 5, then you could do that in that data frame, because now you're just seeing for all the movement features as columns. You're seeing all of the frames as rows. So it's just this big giant table of data. And that's one way to visualize it also. Okay, so let's move on. So I have Aiden next, but I think he just dropped. So why don't we go on to Chris?
Right. Okay. Yeah. So I guess, what was it? Sunday. Yes, Sunday. That Mike and I spent a little bit of time talking about how to get an output similar to what the Schaefer lab has for their basically these visualizations of the various features and how they compare between the control or natural worm and then the mutant. So let's see. Share my screen. Just in case anybody hasn't seen. But yeah, these basically this document with all of the histograms comparing the different attributes for the two worms. And the very rough approximation that I have right now is this. And basically what I did was I took Michael's code and just added some to it to basically output these grids of subplots and compile it all into a PDF. Obviously, big next step is making it so the PDF is actually readable. Obviously, the text is kind of a mess right now, so I'm kind of looking through the original Schaefer lab code, and it looks like the code they used to actually build their PDFs is in the util subdirectory. So I was going to look at what they did to format or to get this the font and the spacing to work out.
They also show like 6 plots per page, I guess. So we're showing more than that. But even if it was 6 plots, yeah, there'd probably still be some text overlap.
Yeah, well, like so the first two. So yeah, what they do is they've got the first 2 pages.
Oh, sorry. Yeah, you're right. Yeah, the 4x5 first page, first 2 pages.
Yeah, this is going to be the most difficult. But yeah, I mean, basically just trying to get it to look somewhat similar to this. I mean, identical is not really the goal, but you know, readable and nice. Obviously, the other thing is they use a color coding scheme, which is nice. Like, so they've got their Q values coded into the color of the background.
Yeah. Now, I actually implemented that, except that nothing is statistically significant in ours right now. I think that it should be implemented. In fact, I used a color picker to like pick exactly the colors that they used.
Oh, okay. I'll have to look and make sure that what should be basically make sure that my plot code isn't masking that somehow.
Fair enough, yeah.
But okay, I'll look for that. And
basically, the issue that we're plagued with is that if the statistics is giving Q values of greater than 0.5 or 0.05 for every plot, then they're all going to show white, because it only starts showing colors with a Q value lower than 0.05.
Well, I can test it by. Yeah, I'll just look through. I'll find. Do you know where is that?
It should be in wormstatistics.plot.
Okay, because I could just monkey with that value.
Right.
Where it starts. Because yeah, it would. But yeah, so that's.
That's awesome. Okay, so yeah, so Chris, we'll keep working together on that and hopefully try to get this closer to be the output, because I know that Andre Brown, for example, would be excited to have a way to redo those PDFs, given his interest in writing a letter to Nature Methods and getting that published that discusses how we replicated the results of the Yamini paper, the original one. So if we could create the same thing and then compare them, then we'd be well positioned to be able to provide the data for that letter. Cool.
Well, so graphs.
Yeah. Okay. Let's see. So Chris, is that anything else, or can we move on?
Oh yeah, no, that's probably enough rambling for me.
No, that's great. That's super exciting. Okay, Aiden, I see you're back. Do you have the ability to give an update on your behavioral syntax code?
Yeah. So first, I'd like to clarify that I did not work on implementing Andre Brown's motif analysis code in Python. I worked on his behavioral syntax paper. Well, the code that supported that paper because based on just reading the motif analysis paper and talking to Balazs about it just afterwards, I realized that it made too many assumptions and actually it did not conceptually it did not really work very well. Basically, motif analysis, the way Andre Brown did it with a few other researchers, involved decomposing, well, analyzing sequences of postures and associating and considering those behaviors. But basically, you can have subsets of postures of sequences which are included within each other, and then you think, wait, so which one are you analyzing, and which one is the behavior, which one, and then you basically end up looking at sub-behaviors and more meta-behaviors, and it just did not strike me as a very good tool for comparing worms, whereas behavioral syntax was about trying to discretize locomotion and developing an n-gram model, and from a common set of postures, Andre Brown settled for 90, comparing the locomotion of worms using that n-gram model. He settled for a trigram model, and basically for that reason, I just conceptually it made more sense, and actually I discussed with Andre Brown as well. So he agreed that it actually was a better scientific method for analyzing locomotion in comparing locomotion of different worms. So basically, if anybody wants to work on implementing motif analysis in Python, I think that can still be done. But I just thought, based on my discussion with Andre Brown and Balazs, implementing behavioral syntax in Python was probably a higher priority. So anyway, that has been going on. I can give the link to my GitHub repository where that's happening. And
Aidan, can I ask you a question?
Right now, yeah.
So that makes what you're saying makes sense, especially if you've talked to Andre Brown about it and he agrees. Then, geez, well, who are we to say anything about that? So, question though, is this something? What is the output of this that we would eventually perhaps see in movement validation? So, I guess we'd see this sequence of items that are postures, I suppose. So a sequence of postures would be the data that we would get out of this for a given worm. Then, so we'd have some array, some NumPy array of these postures that the worm adopted throughout the video. So you'd be breaking down a given video into these postures, and that's what we would get. Is that the idea?
Wait, let me go back. Where's the discussion? I'm trying to find the. I would need to comment somewhere. Where's this Google Hangout thing? I switched computers actually because the laptop I was using for some reason just crashed, and now I'm using my sister's MacBook, but I don't know how to use it. I'm not familiar with this thing. Basically, the way the trigram model works is that since you have 90 postures and you've got a trigram model, what I understand is you have 90 times 89 times 88 possible trigrams. So those are the possible sort of trigrams that a worm can use. It's sort of a language in some sense, and by comparing the frequency of use of those trigrams and also the probability of the likelihood of certain transitions, likelihood of certain trigrams, you can compute the probability that two worms are alike. So yes, you have all those intermediate calculations. You'd have, for a given video, you'd have a sequence of postures, and from there you could determine whether it's a real worm or it's a simulated worm, if there is a significant difference.
Can I
I
ask
should probably
one
cite.
question?
Yeah.
Chris, just referencing the paper, I think. Sorry, I just noticed that Aiden, you hadn't put up the link to your GitHub repo. In that repo, it mentions the paper. The link is in there.
Right,
But
exactly.
Aiden, a quick question for you, just to see if I'm understanding things right. Each individual posture is it could consist of multiple frames of data. Is that correct? Like one of those 90 postures, would those would occur over multiple frames of data?
Yes. So basically, he uses a simple time warping method, and he basically compresses the sequences. So if you have got a frame that follows another frame, which are mapped to the same posture using k-means clustering, then those are collapsed, and so let's say AABC becomes just ABC, and that's a small issue. Actually, I discussed this with Andre Brown by email, and in his paper he mentioned that he considered that another thing that he would consider analyzing would be the time spent on in each posture, which he didn't have time to analyze. And that's a feature I can definitely add, because I think that would help sort of focus the microscope on the differences between worms. That would look into the dynamics, actually.
Yeah, it would also be interesting to see the autocorrelation between the length of time spent in each posture over different different points in the, or whether or not that syntax is temporally a unit as well. Like I don't know if there's a noticeable, like, basically if a posture has a certain I think that a certain natural time span that the worm spends in that posture, or if that time span is highly variable, would be interesting. Because
yeah, that's a good point. I definitely think that, let's say, the more coiled postures would be the ones where worms would spend more time. That's something that could definitely be analyzed once I add that feature where we look into the time spent in each posture. That could definitely be done, and I think it would definitely be simple to add.
yeah, because
one of the basic
sorry.
Yeah, one of the basic things Andrew Brown mentioned was that we can just start by looking at histograms, and for each worm, given a particular video. So yeah, we can definitely start with that. And the thing is, I wouldn't want to talk too much about that yet, because first, I think what I should do is finish the plotting library, get done with getting that implemented in Python, and then talk with Andre Brown, maybe Skype with him regarding further analysis that can be done investigating the dynamics of those sequences.
Aiden, what plotting are you referring to? I'm looking at the paper right now, and is there like the plotting the postures, for example? Like I see there's these plots where the skeleton is blue and the head is red.
Actually, the thing is, I haven't I haven't tested any of the plotting code yet. I've just been focused on compression and the utilities required for compression and discretization. So I haven't looked at I think a basic thing that can be done already with plotting is just basically visualizing the differences between the sort of vocabulary that different worms use. I mean, there might even be certain. I think in the paper he mentions that there are the difference between different worms, different species of worms, is due to a small subset of their available vocabulary of movements. And the analogy he uses is that between, say, different English speakers, you can distinguish, say, an Australian person from an English person just based on the slang terms they use. And so, yeah, so it reduces the dimensionality of the problem, like the comparison problem. Yeah, I've not really worked on plotting yet. I haven't tested any of that.
Okay, because I can see that this work connecting in various ways to the movement validation repository and to our work. Like I can see it, entering in the sense that we need for this work here, we need a well-characterized input and a well-characterized output for this. So your input would presumably be the skeleton over time, and then the output would be this list of these postures, this behavioral syntax over time, or I guess not over time because you've now discretized it, and you've removed the time element, I suppose, and then also recording how long each of the worm remains in each of these postures. So I guess it would be a two-dimensional. Anyway, so I have to think about exactly what the output would look like, but characterizing exactly what data array is the output of all of this work in this package would be useful. And then with that, then you could create plots and run various statistics, and we could compare it to the existing features that we have right now and see what's more useful in various ways. So I could see a lot of work, but if we embed this within the movement validation work, I could see there being some advantage to that. Anyway.
Well, actually, what I see right now actually is I can say it clearly. The main output for a video would be, let's say the video has n frames. Would be the main output for a video of n frames would be an array or a list of n postures. You see, so that could then be collapsed using Andre's compression method, and then yeah, that array or list, whichever you prefer as output, could be analyzed in more detail and used to compare different videos. I'm not sure how it fits exactly with the existing movement validation pipeline, because in some sense it is much more minimalist. They don't look at, say, the turning rates of the worm wavelength, and a bunch of other things. He has really reduced it just to, say, 90 postures and a trigram model. But I think it would be interesting to see how it, say, can be used to maybe an alternative movement validation procedure. I'm not sure how it can. I'm not sure exactly right now how it can be used within the movement validation framework, because it seems to be from just right now it seems to be a very different approach.
Well, I certainly agree that the statistical techniques that would be used to pull out interesting information and to try to distinguish worms would certainly be different than what Evumini and what the Schaefer lab did with the behavioral database, trying to just show these histograms and then compare them in that way. But I guess what I'm trying to say is that the data pipeline that the movement validation repository has created. Like, for example, all of Jim's work with the features there and the dependency system that he's created there for how to calculate them. I feel like you could totally plug in at least the behavioral syntax calculation work into movement validation. So you plug it in. You can ask of movement validation here. Here's a skeleton or here's a video. Give me the behavioral syntax, and then you can take that and do with it what you want. Anyway, maybe we should move on. But that's really cool that you've made some progress there for sure.
Can I add 2 points onto that, just in terms of the practicality? First of all, and this is really awesome stuff. I'm super excited about it. To reiterate on what Michael said, I think at the end of the day, and this is something we're I think in the process of evaluating how to best do this. At the end of the day, the goal of this movement validation repo is simply to provide some mechanism by which we can compare these simulated worms to real worms. I don't want to think of it as being limited to some processing pipeline that's largely determined by what the Schaefer lab has done previously. So if in the end, if we work it out, maybe at the end of the day, the comparison method that we're using is basically the behavioral syntax approach. I think that's what we care about, not necessarily forcing things into these other to look like these other features. So I really think that this will fit nicely in with our bigger plan, and I'm super excited about it. Perhaps more importantly, and what I think is useful for this group to consider, and perhaps other people that aren't here as well, is just from a logistics standpoint, how are we going to go about using this code, and from like an organizational standpoint, I think that's something that's not clear. So more specifically, what I mean is, right now this repository is is your own repository.
Yeah.
It's on its own. I'm not opposed to keeping it. It's sort of like having it be the behavioral syntax repository. But I think what we need to think about is, how do we expose it to the other code? How do we start to bring it in? And I think this is going to become a bigger issue as we start talking about, especially with these other groups, of them using our code. And I brought up to Stephen and Michael earlier, there's some concern over, some people might only want our code just for the feature processing pipeline. They might not care about the true movement validation aspects of it. And so I'm very much open to suggestions from the group as to how do we allow for everyone to do sort of their own development, but at the same time do these tie-ins so that we can actually use code across repositories, or alternatively try and force things into a single repository, or whatever the thing may be. So I'd open that to everybody for comment if you have any at this point.
I guess we could, as far as pulling from other repositories, I guess as long as, I guess we could make wrappers for the external code, like for Aiden's code, have a facade for his code inside the actual movement validation repository, and then it just imported as a module, and basically use that facade to access his code if we don't want to integrate, pull his repository into ours completely.
I think that's one approach. My personal opinion on this is, as much as possible, to have people edit the movement validation repository itself. If it's a huge, completely different thing, then maybe it makes sense to have a wrapper around it and to make an API call to ask it to calculate a feature, and then to save it to the database in movement validation. But it seems to me like we've done all this work to try to make the code well commented and well structured, precisely so that it's inviting for people to come in and potentially add a feature or two or something. And this, to me, is just another feature. It's behavioral syntax, sure. It requires different approaches to analyze it, but it's just another piece of data. Starts with skeleton and then it ends with piece of data. And so having this in movement validation, I think, is the most logical place. But of course, I can't make anyone do anything, so it can go where people would like it to go. But I think maybe the goal of open source, or one of the great things about open source, is that you can't make anyone do anything. So all you can really do is make something as inviting and as nice as possible. So hopefully people will be interested in contributing in the way that you want them to. So that's always been my thought when I'm trying to make the comments and the code look really nice and everything be really pretty, so that people want to come and make a contribution directly.
Yeah, I mean, maybe we need to take this on a case-by-case basis, but you know, to some extent, I get nervous about telling people, oh, by the way, this is great, but you really should just be forced into the group, and you know, it's not any good unless it's coming from us, you know, or I don't know. I'm just a little nervous about forcing people to come into it. I think in the end, I might agree that it'd be nice to have that, but I don't know. Steven, do you have any thoughts on that, or?
I want to reinforce case by case. So I think that you want to generalize only after you have some examples of folks coming in and wanting to reuse stuff, and rather than predicting what a user might want to do in advance and then leading to a lot of code that may never be used, or doing a lot of unnecessary sort of decoupling before it gets used.
Sure.
I think, yeah,
Sorry,
I think
go ahead.
the critical thing is just to really assemble use cases that folks like actually are chomping at the bit for, and then making, you know, something that can address those to solve the immediate problem, and then coming back refactoring later in general.
Okay, that's a very good point. Can we if and I apologize, things are, I don't know what time we're supposed to end, but what are we doing in this case then? Like, what's the plan for this particular repo? Aiden, I don't know if you have thoughts on that, or guys, if you have thoughts on what's going to happen, but is it going to stay as it is, or are we going to take it over, or what?
One thing, well, there are two things. First, I think that first I should get it done, like not just have it all implemented in Python, actually test everything. And I haven't actually done that. I mean, I put percentages on each section of code I've implemented, and if it's less than 100%, that means I haven't tested it fully with everything else, and so not absolutely certain that it works as it should. If it's 80%, then that means the syntax is correct. It gives you an output that you know, that makes sense. But that's the first thing I should get done. And second, what I did, I'm not sure whether this is the standard procedure, but I tried to name each Python program this in the equivalent way that Andre would have named his MATLAB programs, so that someone that is trying to go to this program, no, to this repository, after reading Andre's paper, could just double check, go back to say Andre's MATLAB code and see that everything's the same, or compare for differences, because as I said, I'm thinking of adding a few functionalities that are not in the existing MATLAB code. But that's a procedure I followed. I'm not sure whether that's a standard procedure, or what do you guys think about this?
We definitely, Jim and I definitely have some thoughts on that. That's for sure. So we've gone back and forth many times about, you know, how closely do we care about following the naming and the structure of the Schaefer Lab code, and basically, I think at this point we probably both agree that we've completely laid waste to any of the structure, the naming, everything, that they originally had. Everything is different. It's all in classes. It's especially with Jim's refactoring, it's completely different. It's lazy evaluated. It's very different. The only thing that we really cared about, ultimately, as it turns out, is functionally emulating the output. So it's the same output. And in this in the specifications table that we have, we're careful to have the old names for things recorded on one column of the table, and then our new name also beside it. So you can still look up things by the old name. But certainly trying to go line by line in the code and find it, that would be not possible with our approach. So for example, if you were to bring in your code into our repository, I'm just looking at this right now, like it would be like if we were to try to follow the same code approach that we've been using, a lot of things we would change, like even like variable naming we would change to be more Pythonic, other stuff like that. So that's definitely that approach that you're taking to try to make it the same as MATLAB in terms of naming everything has a tension with our philosophy and movement validation for sure.
Okay.
For better or worse.
But at the same time, like you said, I would focus on getting it done the way that you can. And
Agreed. Yeah.
once it's done, we get some of those more tests in place, then we can worry about the details. It's not and maybe the only thing to take out of that is don't kill yourself over matching things exactly. For what it's worth. Just to get back to the other topic I had, and I guess let's maybe table the question of what we're doing in this particular repository until a later point in time. The other one, Stephen, I had in mind was the work that's going on in Andre's group with the multi-worm tracker. And we had talked about bringing in aspects of their code, and then you were just starting to get into the point where things are sort of reaching across, and I don't know if at any point in time we need to have a more well thought out plan for these things. But at this point in time, it's not super critical for me. I see it coming down the road, so maybe it's something for people to think about.
Maybe we should open an issue on this precise subject. But yeah, I think you might have a point.
Yeah.
Yeah, and I think also maybe to take it up as a specific agenda item, as a discussion point for the next opportunity.
Yeah, I mean, keeping in mind, of course, the goal is always to have as broad and as deep a collaboration as possible with as many people as possible. I guess we have to evolve and figure out what the best approach is to make that happen. So if it happens to be closer to what Aidan's doing, then great. If it happens to be closer to what I'm suggesting, then also good. Okay, so maybe we can move on here. I see Stephen, perhaps maybe you could discuss briefly what you've been working on. And for example, the fact that you gave us that extract to Dropbox. I don't know if there's anything else to add, or if you have anything else to comment on with respect to the Shaver hard drive.
Yeah. So I could really use another hackathon of this group, because when we're all together here and everybody's hacking away, and I'm included, then that's the natural thing that I end up doing. A lot of my OpenWorm time lately is going to writing up an SPH paper and making sure that our Google Summer of Code student on the modeling side is free from roadblocks on his summer project. But since I did attend the Worm meeting this past 2 weeks ago or so up in Los Angeles, I attended a Worm Tracker workshop. I was able to point the community at the Movement Validation Project. Andre Brown, who was chairing the workshop, gave me the floor to do that. And what came out of that was some goodwill towards the idea of building community around worm tracking. And so there was a mailing list that was started, and then I decided to take it upon myself to create this GitHub repo here, which I'm pasting in the chat, that basically just compiled a bunch of things that people were saying about like requirements, with the idea being that that this could end up just being just a document. It could be the basis for a very simple GitHub page that turns into a website. Or if the community wanted, it could start to be a rallying point for, like, another thing would be like a list of different open source trackers potentially that could be on there. And so I wanted to leave it pretty open for folks. So that I think I made this about a week ago or so. And so what's on the page right now, I guess we can look at it, are some things that folks said they might want to have in terms of standardizations and that kind of thing. And so there are a list of universal formats that folks are sort of talking about proposing, a list of candidate metadata that somebody threw out, discussion of JSON as a candidate format, some discussion of various image formats. And so each of these could have came from some different folks. And so I guess I would just throw open the floor to say, is this something that we want to expand or add to? How should we be thinking about engaging this particular community that came out of this Worm Tracker workshop beyond what we've done? I know that we've invited them to come to this meeting. I don't think any of them replied, and they're not here now. So do we want to do more to try and reach out to these folks, or is there more I can do to help reach out to these folks? I don't want to sort of create additional obligations and burdens for anybody here, and I know that Jim, Michael, and I have talked about it. But at the same time, we're talking about the community of folks that are actually tracking worms and generating data, and so it does seem like an opportunity for the stuff that we've done to make its way out there if we do engage them directly. So, thoughts on that?
Well, first, thank you so much, Stephen, for doing that, for being our mouthpiece at that meeting. That's fantastic. And yeah, I mean, to the extent that we can facilitate this discussion, I think it's great, because then we get feedback, and so we know that what we're building is potentially going to be of use. So even if they're not contributing directly, having their feedback on this sort of open worm tracker standard, I think, and building consensus around the idea of even having a standard, I think can only be good. So to the extent that we can participate in that discussion, we definitely should, in my opinion. So I'll certainly, for my part, try to participate in asking questions and codifying some of these things, in particular around the metadata part, because that's sort of been a piece that I've been working on in movement validation, getting the right metadata recorded and getting it serialized in JSON. And soon I'll be writing something that has to batch process all of these videos, for example, and so therefore pulling out all of this metadata will also be another part of that, and that'll be something again to care about in terms of exactly which pieces of data we're going to be recording in what order, and how we're going to name everything.
Okay. Cool. Well, we can just go from there.
From there, awesome. Okay. Cool. Well, yeah. Again, well, thanks so much for that. Okay, so that's, I think, the last update for this meeting, and I think if we count forward from when we started this on air, I think we are at about 1 hour right now. So I'll just end this with my traditional appeal to people who are watching but not participating in this meeting, that there are certainly places where more work needs to be done in the movement validation repository. So feel free to reach out to myself or any of the people currently attending this meeting right now that you see on your screen. We need certainly more documentation, more unit tests to be written, and lots more interesting things that you can see in the issues. So feel free to reach out, and we can help point you in the right direction. So I've written down here that our next meeting could potentially be on Friday, August 14th. Does that work for everyone in the room? This would be the same time, but 4 weeks from now?
Yeah.
Yeah.
I'm getting nods all around. Okay, so we'll obviously continue this discussion offline, but until then, until the next meeting, let's keep working away.
Thanks, guys.
Thanks,
All
guys.
right. Yeah. All right.
All right, buddy.